HCF, highest common factor, LCM, least common multiple. There's a very important relationship between any two given numbers and their HCF and LCM. And the property is this. The product of the two numbers is equal to the product of their HCF and their LCM. If I write it down, let's assume that my two numbers are A and B. Then the property is A multiplied by B is equal to the HCF of A and B multiplied by the LCM of A and B. For example, if I assume the value of A is 4 and B is 6. Now, the highest common factor for 4 and 6 is 2 and the least common multiple for 4 and 6 is equal to 12. 4 multiplied by 6 is 24 and the HCF 2 multiplied by the LCM 12 is also equal to 24, hence proving that the product of these two numbers is the same as the product of their HCF and LCM. So there are questions which will come from the first chapter of the NCERT textbook, the chapter on real numbers, where you will be given two numbers, you have to find out their HCF, their LCM, and to confirm this property that the product of two numbers is equal to the product of their HCFs and their LCM. So let's take a look at examples and see how this can be done. So find the LCM and HCF of the following set of numbers using prime factorization method. Verify that the product of the numbers is product of their HCF and LCM. So first, let us prime factorize 20. So this is 2 tens are, 2 fives are, and 5 ones are. So 20 is nothing but 2 square multiplied by 5 to the power 1. And prime factorizing 32. 2 16s are, 2 8s are, 2 4s are, 2 2s are, 2 1s are. So 32 can be written as 2 to the power 5. So the common prime factor is 2 and the smallest power is 2. So the HCF of 20 and 32 is 2 to the power 2. What is the LCM of 20 and 32? So both 2 and 5 are the primes. The larger power is 5 and for 5 it is 1. So the HCF is 2 square, which is 4. The LCM is 2 raised to power 5, 32 into 5, which is 160. Now let's verify the property. 20 multiplied by 32 is 640 and 160 multiplied by 4 or 4 into 160, 16 4s are 64, add a 0. And here we see that the products of the two numbers are the same as the product of their LCM and HCF. Hence, we have proved that for these two numbers, these are the prime factors using the prime factorization method, and the two products that we require are exactly the same. Let's take a look at another example. Now, 45 and 65. First step, we need to prime factorize the numbers. So, 45 is 3 15s are, 3 5s are, and 5 1s are. For 65, we have 5 13s are and 13 1s are. So 45 is 3 square into 5 to the power 1. 65 is 5 to the power 1 into 13 to the power 1. The HCF, the common prime factor is 5. The smallest power is 1. So that is 5. The LCM, 3, 5 and 13 are all prime factors. Largest power of 3 is 2, largest power of 5 is 1, largest power of 13 is 1. So 3 square is 9, 9 into 5 is 45 and 45 multiplied by 13 we get as 585. So now we need to verify that 45 multiplied by 65 is the same as 5 into 585. So 45 multiplied by 65. 6 5s are 30, 6 4s are 24, 27, 5 5s are 25, 5 4s are 20, 22, 5 2 9 2. So 45 multiplied by 65 is 2925. Let's take 585 multiplied by 5. So 585 multiplied by 5. 5 5s are 25, 2 carry, 5 are 40, 2 carry, 4, 5 5s are 25. So we also get 5 multiplied by 585 is 2925. As we can see, the two products are the same. Hence, prime factorization and the product of the numbers and the product of the HCF and the LCM is exactly the same. Let's take a third example, 52 and 169. Let's prime factorize 52. So get to 26 are, 2 13s are, 13 ones are. So 52 is 2 square into 13 to the power 1. 169, 13 13s are, 13 ones are. So 169 is the square of 13. HCF, the common factor is 13, power 1 is 13. LCM, all the factors 2 and 13, largest power of 2, largest power of 3. So this is 169 multiplied by 4. 9 4s are 36, 24 and 3 27, 4 ones are 4 6. So this is 676. Now 52 multiplied by 169. So 169 multiplied by 52. 5 nines are 45, 5 6 are 30 and 4 34. 5 ones are 5, 8. 2 nines are 18, 2 6 are 12, 13, 2 ones are 2, 3. So this is 8, 7, 8, 8. On the other hand, 676 multiplied by 13. So 676 multiplied by 13. So 3 6 are 18, 3 7 are 21, 22, 3 6 are 19, 20. So this is 8, 7, 8, 8. And as you can see, the product of the two numbers is the same as the product of their HCF and LCM. Okay, 91 and 143. Let's prime factorize. So 91, 7 ones are, 3s are, 13 ones are. So 91 is 7 power 1 into 13 power 1. 143, 13 ones are 13, 13 ones are, 11 ones are. So 143 is 11 power 1 into 13 power 1. So the HCF of the two numbers, the common 13 1, which is 13. LCM, take all the prime factors and the maximum powers, which is in this case 1 1 and 1. So 7 into 11, 77 into 13. 3 7s are 21, 3 7s are 21, 23 is 1001. So 91 multiplied by 143. So 143 multiplied by 91. 9 3s are 27, 9 4s are 36, 38. 9 1s are 9 and 12. 1 3s are, 1 4s are, 1 1s are. So 3. So this should be 13013. And now I'm going to do 13 multiplied by 1001. So 1001 multiplied by 13, 3 ones are 3, zeros are 3 ones are 3, 3103. So this is 13013. Some product of the two numbers is the same as the product of their HCF and LCM, hence proved. Now, LCM and HCF of 156 and 204. Let's first factorize 156. 2 7s are 14, 2 8s are, 2 3s are 6, 2 9s are, 3 13s are, 13 1s are. So 156 is 2 square into 3 into 13. 204 is 2102, 2 5s are and 1s are, 3 1s are and 7s are, and 17 1s are. So 204 is 2 square into 3 into 17. So the highest common factor, both 2 and 3 are common, 2 square and 3 power 1. so is 12, and the LCM 2 into 3 into 13 into 17, and maximum powers to 1, 1 and 1. So that is 12 into 13 into 17. 13 12s are 156 into 17. 156 into 17. 1 6 are 1 5 are 1 1 are 7 6 are 42. 7 5 are 35, 39. 7 9 are 7 10. So 2 6 5 2. Now we need to verify whether 156 into 204 is 12 into 2652. So 156 multiplied by 204. 2 6 are 12, 2 5 are 10, 11, 2 1s are 2, 3, 4 6 are 24, 4 5s are 22, 4 1s are 4, 5 6, 4 2 3 1 8 2 4. So 156 into 204 gives me 31824, and here HCF is 12, LCM is 2652. So 2652 multiplied by 12, 2562. 2 2s are 4, 2 5s are 10, 2 6 are 12, 13, 2 2s are 4, 5. So 4283184. So 12 multiplied by 2652 is 31824. The product of the two numbers is equal to the product of their HCF and LCM. Hence, once again, we get a confirmation of this particular property. Now, let's take a look at 175 and 225. Now, 175 divided by 5 3s are 15, 5 5s are, 5 7s are, and 7 1s are. So 175 is 5 square into 7. 225, 3 7s are and 5s are, 3 2s are and 5s are, 5 5s are and 5 1s are. So 225 is 3 square into 5 square. So the HCF, the common factor, is 5 square. LCM is 3 square into 5 square into 7. So 9 into 15, 225 into 7. 225 multiplied by 7. 7 5s are 35, 7 2s are 14, 17, 7 2s are 14, 15 is 1575. So HCF is 25, LCM is 1575. Now the product of the two numbers, 175 multiplied by 225. So 175 multiplied by 225. 2 5s are 10, 2 7s are 14, 15, 2 1s are 2, 3. 5 5s are 25, 5 7s are 35, 37, 5 1s are 5, 6, 7, 8. So I get my answer 35875, 35875, and 25 into 1575. So 1575 into 25. 2 5s are 10, 2 7s are 14, 15, 2 5s are 10, 11, 2 1s are 2, 3, 5 5s are 25, 5 7s are 35, 37, 5 5s are 25, 28, 5 1s are 5, 6, 7. So this is 573937375. So I need to cross check my calculation. 175 into 225. So 2025 are 10, 2 are 14, 15, 2 are 2, 3. Oh, I missed one number here. Okay. So we need to correct this calculation. So 2 5s are 10, 2 7s are 14, 15, 2 1s are 2, 3. 2 5s are 10, 2 7s are 14, 15, 2 1s are 2, 3. 5 5s are 25, 5 7s are 35, 37, 5 1s are 5, 6, 7, 8. So 5, 7, 3, 9, 3, 7, 5. And yes. Now we get this is 39375, and 25 multiplied by 1575 is also 39375. So the product of the two numbers is equal to the product of their HCF and LCM. You just need to be very careful with the factorization, the prime factorization of the given numbers, and then the multiplication. Usually we don't get too large numbers like this, but even if you do, if you're careful enough with your calculation, you will definitely get the right answer. Practice a lot more examples and you will get mastery over this fundamental, that the product of any two numbers is equal to the product of their HCF and their LCM.